Good afternoon, everyone. I hope you've been enjoying re:Invent so far. I'm really excited to be here to talk to you all about how you can build a multi-region serverless application with AWS AppSync. Before I start, let me quickly introduce myself. My name is Ozioma Uzegu, and I'm a senior solutions architect at Amazon Web Services based out in our offices in London. I'm also part of the Builder Experience Specialist team within AWS, where I specialize in services like AWS AppSync, AWS Amplify, and AWS Device Farm. Throughout this year, I've been having a lot of conversations with our customers about how you can deploy AppSync in multi-region, and I'm really excited to be here to talk to you about some of the learnings and also to share this topic with you as well. But before I start, a quick show of hands. How many of you here are running GraphQL APIs in production? Okay. How many of you here are using AppSync to run your GraphQL APIs? Okay. And how many of you here do not think you should use AppSync for your serverless GraphQL APIs? Anyway, I think you all are in the right place. So here is the agenda of what we're going to cover today. But before that, let me do a bit of housekeeping. I've got QR codes sprinkled throughout the presentation, so feel free to take a picture and scan for additional information on the slide. I have a number of architecture diagrams I'll be building out as we go along. So just use this sign in the middle to know when the architecture diagram is complete so you can take a picture. And finally, this is a 300 level talk. So most of the content will be at 300 level, but I'll try to go 200 level or 400 level to also explain the topic of discussion, okay? So here's the agenda of what we'll cover today. I will level set by doing a quick introduction to GraphQL and AWS AppSync. I will then move on to why multi-region deployment of AWS AppSync, looking at some of the use cases. We'll then go through some of the architecture patterns for setting up AppSync in a multi-region deployment. I will then talk through about some of the things you need to think about when operating your AppSync in multi-region, things like how you manage failover, and also things around authorization. And then I'll move on to the most interesting part of the presentation, which is a demo. So I've got an AppSync deployed in multi-region, and I can kind of show you that in a demo. And then I'll leave you with a list of resources to help you get started. So what is GraphQL? So GraphQL is a query language for your APIs and a runtime for fulfilling those queries against your existing data source. It works as follows. You describe your data using GraphQL schema definition language. So you can see here, we have a type to do and the fields and a type for each field. You ask for the data you want using GraphQL query, or you can also do a create, update, or delete using a GraphQL mutation, or you can set up subscription to listen to changes to data using GraphQL subscription. Here, we are asking for the list of to-do, but only asking for the name of the to-do. And then you get predictable results. So here you could see we are getting the response back from our AppSync server, and is representing only the name of the to-do which we've requested in the query. So what are the key benefits we've seen why customers are adopting GraphQL? I think for me, there are three key benefits. So the first is that it eliminates overfetching and underfetching. And think about if you're building applications that need to cater for a wide variety of client types, this is really important. And if you also think about how your teams are built up, so it helps to decouple the front-end team from the back-end team, enabling the front-end team to drive engaging UIs without always requesting the back-end teams to change the API design. And one of the key features of GraphQL is the built-in support for pub/sub APIs. So if you're looking at building APIs to provide WebSocket connection, you can easily achieve that with your GraphQL APIs, things like chatting application or live sports score. So, but how does GraphQL achieve this? So GraphQL consists of a GraphQL schema and a set of operations. Let's first focus on the schema. So with schema, you define the types within your schema, and this could be custom types to model your application data or GraphQL types like queries, mutations, and subscriptions. Here you could see we have a type to do, like we saw again, with some fields like ID, name, and type for each of those fields. One of the things to also notice there is that you can see the status, which is a to-do status, which takes an enum, which can be done or pending in this case. So just to give you a feel that you can have types related to each other as well. So to carry out a read operation on your data, you need a query. So for example, get to do, as you could see, or to do a create or update or delete, you need a mutation. Or to set up a subscription for your clients to listen to changes to data via WebSocket connection, you need to set up what we call subscription. So here you can see we are setting a subscription for any new to-do that has been created to notify the client. And you can see something as well with this set of operations. So here we are defining ID and name for the get to do. So you have the flexibility to return only the data you need from your data store. So what is AppSync and how is it related to GraphQL? So AppSync is a serverless GraphQL and PubSub API service that really simplifies building modern web and mobile application. When I think about AppSync, there are three key features. So first is that it simplifies application development by providing a single API endpoint for you to run your creates, your updates, your query, your delete data against your databases or microservices or even external HTTP endpoints. So AppSync also provides a built-in PubSub APIs. So if you want to create engaging real-time experiences that automatically publish updates to clients, AppSync can help you set up a WebSocket connection between the AppSync and the clients for your application. And finally, and most importantly, AppSync is serverless. What that means is that you do not need to worry about the underlying physical infrastructure that provides the HTTP, the API, and the WebSocket connection. It's all managed for you by AWS, and only you pay when your APIs are invoked. So how does AppSync work? So AppSync consists basically of a GraphQL schema and a set of resolvers. So resolvers basically take your GraphQL payload, convert them to the underlying system storage protocol, and executes the query on your data source if you're authorized to invoke it. There are a number of mechanisms that you could use to invoke your GraphQL API. So a number of client types, whether it's enterprise app, web or mobile app, IoT apps as well. And you could attach an AWS web application firewall to your AppSync endpoint to prevent from things like web exploits or bots as well. So to resolve your GraphQL queries, AppSync can also connect to a number of data sources, whether these are native AWS data sources like Amazon DynamoDB, Amazon Aurora, or even Lambda as well if you are building your microservices in Lambda, or external HTTP endpoints as well. With regards to authorization, AppSync provides 5 different mechanisms to authorize your API calls, from things like using API keys, AWS Lambda, or Amazon Cognito, or you can also use AWS IAM for resources that have IAM credentials, or OpenID Connect tokens from an OpenID compliant service. And finally, observability is key for your AppSync API. So you can set up for metrics, logs, and traces to ship that using Amazon CloudWatch and AWS X-Ray as well. So why do you need to deploy AppSync in multi-region? Let's first talk about the AWS global infrastructure. So the AWS global infrastructure is made up of what we call regions and availability zone. So a region basically consists of physically separated and isolated availability zones, which are connected with low latency, high throughput, and high redundant networking. And any availability zones consist of one or more data centers. And with availability zones, you can architect your application in such a way that if there is any failure in one availability zone, you can still provide your application from another availability zone. So, but how does this relate to AppSync? AppSync is serverless. So what this implies is that AWS is responsible for the high availability and resilience of your AWS AppSync API within a region. You don't need to worry about that. It's managed for you by AWS. So the question you need to ask yourself then is, do I really need to go multi-region, or can I run my AppSync API in one region? First, let's look at some of the reasons not to go multi-region. First is the additional complexity you have to go through in deploying, in managing, and monitoring your AppSync APIs across multiple regions. And you also need to think about how do you make sure you keep your schemas and resolvers in sync across those two regions. The next thing you need to think about is cost. So even though AppSync is serverless, there are a number of other resources you need to set up AppSync in multi-region. For example, think about the data. Data needs to be duplicated across the regions, and this will lead to also increased cost. And when it comes to routing as well, you need additional resources to set up routing between the different regions as well, which will increase the cost of your infrastructure. You also need to think about data replication. For you to provide a consistent experience for your clients and customers across the various regions, you need to make sure that data is replicated across the regions where you have your AppSync deployment. And if you don't have a data source that supports native replication, you need to deploy and manage that replication yourself. And when it comes to testing, you need to consistently test your multi-region deployment to make sure that you can identify failure scenarios. So setting up things like monitoring and alarm to make sure you can detect when a region is unhealthy and route the traffic to a healthy region. So these are some of the things you need to think about. But having worked with a lot of customers on this subject this year, there are still reasons why some customers are going with multi-region deployment. And I'll cover for you some of the use cases we are seeing on that. So the first one is that customers that want to deploy AppSync API in such a way that they can have business continuity and a sort of a disaster recovery strategy as well. So with those type of customers, they need to provide a near real-time API, so with a near real-time RTO and RPO. And if there is any failure in one region, your API can continue serving from another region. So what does that mean? So if there is any failure in one region, all requests will be routed to the healthy AWS AppSync in the second region. The second use case we are seeing is for customers that need to improve latency for geographically dispersed users. So think about if you have an API, ideally you want client GraphQL requests to be fulfilled by the AppSync endpoint closest to them without having to route to another region that might be far away and can potentially introduce some latency there as well. So for example, you can have some of your consumers in the Singapore region and their requests being routed in the island region. So typically what you want to do is to build your AppSync deployment in such a way that the requests from your consumers, API consumers, will be routed to the region closest to them, thereby preventing that potential increase in latency in making that round trip to a region far away. The third use case we are seeing is for customers that have data residency requirements. So in this case, data will need to be hosted within a geographical region without any sort of data replication between the regions. So GraphQL requests from consumers will need to be routed to the AppSync endpoint that have access to the data store hosted within the region, within the geographical region, to resolve the data. So if you have any of these use cases, how can you go about then deploying AppSync in a multi-region architecture? So the first thing I would recommend you all to do is to think about what is the application requirement you have. So every application is different. I need to understand the application requirement for your particular application. So these are some of the things you need to think about, but I'll pick on some of them. So the first one is, what is the recovery time objective, which is basically how fast or how quickly are you meant to recover, and also the recovery point objective, which is how much data you can afford to lose. You also need to think about the GraphQL operations you need to support. Do you need to support queries and mutation and also subscription, or is that a subset of the operations you need to support? You also need to think about the data consistency model. Do you need full eventual consistency, or must you implement full consistency? And by full consistency, I mean that data needs to be replicated across the regions synchronously. And finally, how about conflict resolution? There might be cases where the same data is being updated by the AppSync endpoint in different regions. How do you decide which update wins? Is this something that your data source supports, or this is something you have to manage within your business logic or your API layer? So these are some of the requirements you need to think about. And once you establish this, the first thing you need to then start looking at is how do you build out a single endpoint for your AppSync API. And in the next set of slides, I will cover for you the options for building that single API endpoint, which you want to achieve with AppSync, and then route traffic to various regions based on the target regions you've deployed your APIs. So what do I mean by routing via single API endpoint? So you have your AppSync API deployed in 2 regions. We'll be using Ireland and Singapore throughout the discussion today. And then you have your AppSync clients sending queries and mutation and subscription to a single API endpoint. You have this middle layer that needs to make a decision on which region to route your request. And I'll cover for you the options here and how you can go about setting that up. Last year, we announced the support of custom domain on AWS AppSync. So this enables customers to bring their friendly domain name on their AppSync APIs. So if you know today, when you create an AppSync API, we generate a URL for you, and that URL is based on the API ID and the region you created your AppSync resource. What you also notice here is that the host name for the URL for running queries and mutation is different from the host name for establishing a subscription notification. So what that means is that clients will need to configure this through URL if they want to support queries, mutations, and subscription. But with custom domain, what we've done is to allow customers to bring their own friendly domain name, one single URL, or one single host name that will support queries, mutations, and subscription. I will be using this capability as we continue our discussion on deploying AppSync in multi-region, especially when it comes to the routing. Now, when it comes to the routing, these are the 2 options available. So the first is to potentially use Amazon Route 53 and Amazon API Gateway as a proxy to forward requests to your AppSync endpoint. This option supports queries, mutations, but do not support subscription. The second option we'll go through is to using Amazon Route 53 with Amazon Cloud Routes with AWS Lambda at Edge. This option supports queries, mutations, and subscriptions. So in the next couple of slides, we'll go through each of the options and how to implement this as well. So let's start with Amazon Route 53 and using API Gateway as a proxy. So here we have AppSync deployed in the 2 regions, Ireland and Singapore, and you've got API Gateway configured as a regional proxy to route requests to your AppSync endpoints. Here is a sample configuration for your API Gateway. So you could see the route path can be anything, but here I've used /to-do API. But the key point there is that the integration targets, the targets for your configuration needs to be the AppSync endpoint. API Gateway have a nice functionality where it can support custom domain, regional custom domain on 2 API gateways in 2 different regions. So you can configure that single endpoint as the custom domain for your API Gateway deployment. And then within Amazon Route 53, whether you are using latency-based routing or geolocation-based routing based on your requirements, so you can simply create a routing policy on Amazon Route 53 to be able to route traffic to either the Ireland or the Singapore region. So the custom domain name will be mapped to the API Gateway endpoint in either Ireland region or Singapore region based on your routing policy setup. And then clients will be able to run queries and mutation via that custom domain. So let's look at the other option, using Amazon Route 53 and CloudFront with Lambda at Edge as well. So again, we have our AppSync deployment in the 2 regions, in the Ireland and the Singapore region. And then we have clients sending API requests to the single API endpoint. You have this middle layer that is made up of Amazon Route 53, Amazon CloudFront, and also AWS Lambda at Edge. Let's unpack this middle layer and how you go about setting up that routing. So you have your client making GraphQL queries, mutations, and subscription. That goes to Amazon Route 53 to resolve that DNS to Amazon CloudFront. So CloudFronts have been configured in such a way that AWS Lambda at Edge runs before the request is sent to the origin of the CloudFront. And the Lambda at Edge does two things. So the first thing the Lambda at Edge does is to resolve the routing based on your routing policy. So there's a DNS you will need to create, and this DNS will basically be the DNS to determine the region you route the request to. So this DNS will be configured as a latency-based record within Route 53 or geolocation-based record. And in this case, for example, the setup is returning island region as the target to route the traffic. The second thing the Lambda at Edge will do is to update the headers of the request. So here, there are two updates that needs to happen. So the first one is the request origin custom domain, and also the host headers need to be updated with the custom domain of the AppSync endpoint in the island region. So these two updates are really important because this is what will enable you to support queries, mutations, and subscriptions. And with that, the request will be routed to the island region, and then the response back through CloudFront back to the client as well. Okay, so we've talked about the two options for routing and how you go about setting that up. Now, let's dive into the architecture. How do you then deploy AppSync in multi-region? So we've covered routing. Think about the use case you have today, maybe a non-critical workload with a RTO, RPO from minutes to hours. So this is how you can go about setting that up. So for non-critical workload, what you can basically do is that you have a single API endpoint and you are routing traffic to an active region. So you've implemented it in such a way that there is only one region that is active at any given time, but you also prep your passive region to send backups of your DynamoDB table to the passive region. So in the event of a disaster, you carry out a couple of actions. First is to restore the DynamoDB table, restore your AppSync API with the changes to the schema and also the resolvers. And in this instance, you can use, for example, a failover routing policy to route all traffic to the passive AWS region, which is now the active region. The second use case we have is for customers that have a critical workload with a near real-time RTO and RPO. For this use case, you really need a data source that will enable replication across the regions. And you also want to make sure that you will keep serving requests, your GraphQL requests, irrespective of any downtime or failures in any AWS region. So how do you go about doing this? The key here is the data source. It needs to automatically do replication across the regions. So we have a service on the platform that could help you achieve that. It's called Amazon DynamoDB Global Table. It is a fully managed multi-region and multi-active database that delivers fast local read-write performance. So how does it work? So when you create a DynamoDB Global Tables, it basically consists of replicas that will be created across the region. So if, in this case, Ireland and Singapore, using our example. And these replicas will have the same name, and they will also have the same primary key schema. And when data is stored in one replica, DynamoDB will automatically replicate the changes to the other replicas. So DynamoDB Global Tables or any other data source you have, it mustn't be this, that supports this type of replication, but also enabling fast local read-write will be a key enabler for you, to enable you to achieve this critical workload with a near real-time RTO and RPO. So let's go through the architecture and how this is going to work. Again, we have our routing deployed, and then you have AppSync, in this case now deployed in active-active pattern with custom domain configured. And then you have your DynamoDB set up as a global table and replication between the replicas as well. And then you have your client invoking your API endpoints, sending queries and mutations. Now you can notice here I haven't talked about subscription. So how do you support subscription in this architecture? This architecture as it is now do not support subscription. And I'll give you the reasons why that is the case. So let's look at the AppSync schema that we've been playing around with. So this is an extract, a little extract from the GraphQL schema for the to-do app we're talking about. You can see the to-do type with the fields and the type for each field. And you can see the mutation add to do and the subscription that is listening to any new to-do that have been added, add to do. Let's go through the architecture layout and explain why subscription is not supported. So you can see again our AppSync deployed in the 2 regions with DynamoDB replication setup as well, global table with replication setup. We have our routing, which we'll be using going forward. And then we have your client. So let's assume you have a client in Ireland, a subscriber in Ireland as well, another subscriber in Singapore. Let's now go through the traffic flow and see why subscription is not supported. So the client sends a to-do, so creates a new to-do. And using latency-based records, the request goes to the Ireland region. Now, this is a mutation, and it should trigger a subscription to all the subscribers. Let's see if that's the case. The subscriber A in the Ireland region receives a notification, but the subscriber B in the Singapore region does not receive the notification. The reason is because the GraphQL mutation was triggered through the AppSync endpoint to the Ireland region. So the subscriber connected to that region will receive a notification. But because the subscriber in the Singapore region is not connected to the AppSync endpoint in Ireland, it will not receive the notification. So the challenge we have here is how do we enable multi-region subscription irrespective of the AppSync endpoint the subscribers are connected to? Let's go through the concept of resolvers and see how we can solve this. So if you're familiar, I've talked about resolvers a bit. So resolvers basically take your GraphQL payload. Through the request part of the resolver, it converts it to the query that the data source understands, runs the query on the data source. The response goes to the response part of your resolver, which is converted to a GraphQL response back to your client. This type of resolver is the resolver that talks to a data source, but we also have another type of resolver called local resolvers. But before I touch upon that, it's worth mentioning that only a couple of days ago, we announced the support of JavaScript resolvers on AWS AppSync. It's worth checking it out. Previously, it was all VTL, which was a little bit difficult for customers to code, but now we support JavaScript resolvers, so worth checking that out. But we have another type of resolvers called local resolvers. So with local resolvers, the requests do not leave the AppSync service. It moves from the request part of the resolver back to the response part of the resolver and then to the clients. And customers typically use this type of resolvers when you want to publish notifications to clients without talking to a data source. So we'll be using local resolvers as a mechanism to achieve this multi-region notification or subscription capability. Let's go through how that will work. So you have your mutation, as we saw before, add to do, that is using the DynamoDB resolvers to store the data in DynamoDB. That will generate a DynamoDB stream. So DynamoDB stream are basically ordered flow of information about changes in your DynamoDB table. This will trigger, you can configure this to trigger a Lambda function to initiate another mutation, which we'll call the add to do publish mutation. So this is a second mutation, different from the add to do mutation, but it basically carries the to do that have been created from the DynamoDB stream. And this will then trigger a local resolver. And this is the mutation your subscribers will be subscribed to, the add to do publish, not the add to do. So this is the mutation that will pass the subscription message to, or the new to do that have been created to the client, and we'll be utilizing the local resolvers to be able to do that. So let's look at what the updated version of the schema will look like. So again, you have your type to do, but you can see the two key changes there. The first change is that we have introduced a new mutation called the add to do publish mutation. And this mutation can be configured to use IAM as the method of authorization, so you can make sure that it's restricted to resources within your AWS account versus someone externally invoking that mutation. And you can also see in the subscription part of the schema, we've changed it from add to do publish. So that's the new mutation your clients will be subscribed to. So this is what it means by a traffic flow then. So again, you have your AppSync deployed in the 2 regions with DynamoDB setup, DynamoDB global table setup, you have your routine setup, you have your clients like we talked about as well. So client makes the mutation request, the add to do mutation, which again routed to the island region, and the AppSync processes the query and creates the item on DynamoDB. DynamoDB will generate a stream, a DynamoDB stream, which will trigger a Lambda function to invoke the add to do publish mutation. Okay? And this is the mutation the subscribers will be subscribed to, and that will trigger notification to subscriber A in the island region. The replication will also replicate data to the Singapore region, which will again generate a DynamoDB stream doing the same activity that we've just heard in the island region, triggering the add to do publish mutation to send notification to subscribers in the Singapore region. So this is how we've managed to solve that ability to achieve multi-region subscription capability irrespective of the endpoint that was used to trigger the mutation. So let's do a recap on that. So for your critical workload active-active pattern, this is the sort of architecture we are talking about. So routing through a single API endpoint down to Amazon Route 53, routing your traffic to CloudFront with Lambda at edge, doing all the changes we've talked about with regards to identifying the region to route the request and also updating your headers. And then you have your AppSync endpoint deployed in 2 regions with DynamoDB global table setup. And then you can also see the DynamoDB streams being consumed by a Lambda function in both regions as well. Now, let's look at the third use case. So the third use case is if you have a real-time messaging use case. So you want to build a PubSub API, or you have an existing application, you want to integrate PubSub into the application. How do you go about architecting this with AppSync? So again, we're going to deploy AppSync in 2 regions with our routine setup. But in this case, we'll be using Amazon Event Bridge. Why? Is because Amazon Event Bridge has a capability called cross-region event routing that enables you to route events from one region to another. If you're not familiar with Amazon Event Bridge, it's a serverless event bus service that helps you to build event-driven applications at scale. So again, we have our clients at the top. Let's go through the traffic flow. So the use case here is, think about a chat application, for example, or you can think about maybe an application that you publish a message to a channel or a set of users. That's the use case we are talking about here. So let's go through the traffic flow and see how this works. So client sends the message. So this can be a chat, hello, for example. It goes to the AppSync endpoint to the island region, and that is AppSync converts the GraphQL payloads and invokes sends an event to Amazon Event Bridge. So there's something that Amazon Event Bridge does. It republishes the message using HTTP destination. So if Amazon Event Bridge has a capability called HTTP destination that allows it to send an event to a particular HTTP endpoint, similar to how we can send an event to, say, to an AWS service. Why we do this is, if you look at the previous slide, is really around how do we still enable that multi-region event routing. This is the mutation that your subscribers will be subscribed to. Because once Amazon Event Bridge triggers this mutation via HTTP destination, that will trigger the notification to your subscribers. Again, the events will flow using the cross-region event routing capability. Again, republishing the event using HTTP destination to the AppSync endpoint, which will again trigger the notification to your subscriber B in the Singapore region. If your publisher is also in the Singapore region, the same architecture will also apply. And if you look at this architecture, one thing is clear: we are not storing the messages or the events. The events are moving from the publisher down to the subscriber. So if you have any requirement to do that, You can also send the events to things like SQSQ, for example, as the target for your events, and gradually consume those events via Lambda and store that to any data store you want as well. So we've covered 3 use cases. So the non-critical workload with RTO, RPO from minutes to hours. We've covered the critical workloads with near real-time RTO and RPO. And we've covered the 3rd use case for real-time messaging. Now, once you've set up your architecture, the next thing you need to think about is how do you manage regional failures? And by that, I mean, how do you make sure that you can identify when a region is unhealthy and route all your traffic to the other region? So this is a simple architecture of the AppSync API deployed in an active-active pattern. I've reduced the architecture just to the key components. There are major sources of failure and things that can go wrong with this architecture. So the first thing can be because of there could be potentially prolonged AWS service outage on your AppSync API or DynamoDB, potentially. Or it can also be due to, for example, you are making manual changes or accidental deletion of your resources within your AWS account without doing any sort of testing, especially for folks that are not automating their infrastructure deployment. It can also be due to security incidents, maybe DDoS attack, for example, or it can be that you've exhausted your AWS service quota within that region, leading to like throttling of your API. So when any of this happens, what you typically want to do is to stop sending traffic to the region that is unhealthy and route all the traffic to the healthy AWS region. So how do you go about implementing this architecture to achieve this? So last year, AWS announced Amazon Route 53 Application Recovery Controller. So it is a service that can continuously give you insights into whether your application is ready for recovery. So with Application Recovery Controller, you can control the application failover across availability zones, across different AWS regions, or even potentially to across on-premises environments as well. One of the main components of Route 53 Application Recovery Controller is the routing control. So it's basically a simple on-off switch that you can use to control whether a traffic is routed to a region or not. So let's go through how you can use that feature as part of our deployment. So the first thing you can do is to create routing control in the for the target regions that you have under consideration. So in this case, the Ireland and the Singapore region. And what Application Recovery Controller will do is to create 2 health checks for these 2 routing controls you've created. So when the switch is turned on, the health check will be unhealthy. And when it's off, the health check will be marked as healthy. So once you get this set up, what you then do is that the DNS we talked about previously for latency-based routing, remember that DNS that kind of routes your record either to the Ireland or Singapore region, while setting up that DNS record, you can use the health check created by Route 53 Application Recovery Controller while setting up those records. So what this then means is that using CLI of your console, if you identify a region is unhealthy, either via monitoring you've put in place or via alarms you've put in place, you can quickly turn that switch off, which will prevent traffic from being routed to that particular AWS region. So what does that mean? So if the routing control in the Ireland region is off, all the requests will go to the Singapore region. And if the routing control for the Singapore region is off, all requests will be routed to the Ireland region. So we've talked about how you manage failovers. Then how about authorization? We talked about that AppSync supports 5 different mechanisms to implement authorization for your API, but not all of them support multi-region deployment. For example, with API keys, this is auto-generated by the AppSync service, and you cannot use the same API keys for 2 different AppSync endpoints in different regions. And then when it comes to Amazon Cognito, as of today, we don't support multi-region deployment of user pools. With OpenID Connect, it really depends on the OpenID Connect provider. Do they really support multi-region? Does it have any sort of regional resilience built in? So it really depends for OpenID Connect. But the two options you can explore are things like AWS IAM for resources that have IAM credentials or AWS Lambda Authorizer. Let's focus on the Lambda Authorizer piece to show you how this could work. So you have your AppSync, again, deployed in multi-region. You can create the Lambda Authorizer for the AppSync endpoint in the two regions we're talking about here, so the Ireland and the Singapore region. So the Lambda Authorizer will be implemented in such a way it returns the same auth token to authorize the API calls. One thing to point out here is that you also need to make sure that if the Lambda function will need to reference other resources within your environment to retrieve the auth token, maybe a data store or any secret store, make sure that that is also created within the region you have your AppSync deployment. Okay, it's demo time. Let's move on to a quick demo of AppSync running in a multi-region deployment. So the demo we'll be going through today is the demo of assuming a critical workload with an active-active architecture, okay? So I've built a simple to-do app here, just back to the theme of the to-do app as well. So this is a simple to-do app that you can fill in the details of the to-do, and it kind of shows you on the list here. Quite a simple, straightforward app. So some of the fields you can see here is the created at, that tells you the time the to-do was created on the data store, gives you that timestamp. It also gives you a view of the region that the to-do was created in. I've just done this for demo purposes to kind of show you the regions that these to-do items were created. On the right as well, you can see a to-do notification that we use to showcase subscription. So if a new to-do is created, it will be displayed within that notification area. So the first thing I'm going to do is to create a new to-do. So I'm going to quickly subscribe so that when I create the new to-do, it's going to be displayed as well. So I'll call this presenting at reInvent. I will copy that and mark that as pending and click on Add To Do. So a couple of things will happen here. So the to-do have been created. On the data store, you can see the timestamp it was created. I can also see the time received, which is the time it was received on the client as well. But I can also see the created in region. The region it's currently created in is EU West 1, which is the Ireland region. Now, let me quickly show you how this have been, just a little bit of code on kind of how this have been configured. So this is a simple React app. For this app, I'm using AWS Amplify GraphQL API libraries. It's important to point here that you must not use Amplify. If you have any other client you are more familiar with to interact with your app, with your GraphQL endpoints, that will also work. But you can see I have, within AppSync, this is the configuration for the AppSync API. So you can see the single endpoint for the GraphQL API. So this is what we're going to use for both queries, mutations, and subscription. And you can also see the authorization method as well. So for the new to-do you just saw I created, this is the code to kind of create the new to-do. So simply using the Amplify GraphQL libraries, and also for setting up subscription, the same applies using the Amplify libraries, and you can also see the static auth token. Again, this is for demo purposes. But what I want to show you now is, we've created a new to-do within the Ireland region. Let's now simulate a user creating a to-do from a Singapore region. For this, I have a VPN service here, which I'll quickly change to the Singapore region to simulate the traffic coming from Singapore. So now you can see we are connected to the Singapore region. So what I'm going to do now is to create a new to-do, testing from Singapore. Okay, I didn't subscribe. Let me quickly do that. So the new to-do have been created anyway, but let me quickly subscribe so we can get the updates. How this one today, pending, up to do. So you could see this is the first one I created, but you could see that this is now created in the Asia AP Southeast one, which is the Singapore region. So you could see at the back end, the API was able, using latency-based routing, to route the traffic to the endpoint closest to the user. Now, let us go down to the routing of how I've set up the routing to help you understand a bit more what's going on in the back end. So I'll quickly, 1 minute. Let me quickly log in. Okay? So let's quickly go to Amazon Route 53 to really see the configuration of the record sets. So this is taking a bit of time. Cool. So first, let's go to the application recovery controller and also open Route 53. Okay? So if you remember, I talked about the Amazon Route 53 application recovery controller, which is a service that could help you to create that routing control to control which region your requests are routed in. So what I'm going to show you is the two routing controls I've created to control the failover. So you can see the Singapore routing control and the Ireland Singapore control. What I'm going to quickly do is to change this to off. So this is basically simulating with the health checks and monitoring I've put in place. I've identified my Singapore region is down. I want to turn it off to make sure that requests are no longer routed to that region. So I'll quickly turn this off. And while this is propagating, what I'm also going to show you is if you open the routing control, you also see a health check that have been created for that routing control. Okay? So for each of the routing control, there is a health check that have been created, and this is the health check we'll configure as part of our DNS records. Let's now have a look at the DNS records to really see how we've set this up. Okay? So there are a number of records we've set up here. So the first record you are going to see, so this is the to-do global api.code.every.com. So that is the same API endpoint that you just saw on the app. So that's the global endpoint that we're using. So what this basically does is to route the request to your CloudFront distribution, as we talked about in the high-level architecture. Then the other routing records are the primary.code.every is basically the custom domain name for the two AppSync endpoints in the two regions. And then where it begins to get interesting is the routing DNS. So this is the DNS that the Lambda at Edge resolves to return the region to route the request. And you can see this latency-based, you can see the latency-based routine has been configured with a health check. So this is the same health check that have been created for us by the routing control. So when the routing control is off, the health check is marked as unhealthy, which will prevent traffic from going to the Singapore region. And when the routing control is on, the health check will be marked as healthy. And let's quickly look at the health check and understand that a bit more. So you can also see from the health check, you can see this is currently marked as unhealthy. So this will, after I switched off that switch, I turned the switch off. So this will prevent any traffic from being routed to the Singapore region. Let's test it and see if that's the case. So I'll go back to the simple to-do app. So you can see we are still connected to the Singapore region. So ideally, you expect this request to be fulfilled by the AppSync endpoint in the Singapore region. Let's see if that's the case. So I'll quickly subscribe again. I'll say testing failover from Singapore. I click on add to do. So even though we are currently simulating traffic from the Singapore region, the to-do was created within the Ireland region, EU West 1. So you could see that with controlling with a simple flip of a switch, we were able to control where the traffic is routed to. And you can set up monitoring in place to make sure that you can keep a close eye on this and maybe automate this process as well of flipping the switch. One thing about the routing control is that we give you 5 endpoints when you create a routing code to be able to control the switch. So even if a whole region is down, you can still be able to control that switch from any of those endpoints as well. Okay, now I want to flip the switch back again to kind of show you that. So let's assume we've resolved anything that is happening in Singapore, all good and fine, health check, the region is healthy, and then we want to recover back to make sure that traffic can still be routed through the Singapore region. What we can quickly do is to go back and flip that switch back to on. So I'm going to go back this, change the routing control, and change it to on. Okay? This will take a bit of time to propagate in terms of the health checks. But while that is happening, let me quickly show you a couple of other things around the setup we've just been demoing. So if I quickly go to the AppSync deployment, let's quickly open that. And I'll also open the DynamoDB so we can see the global tables as well. Cool. So with the AppSync deployment, so the to-do we have here is called the to-do GraphQL API. Let's have a look at the schema. So this is the type to-do we talked about with the various fields. You can see the mutation add to-do, and you can also see the add to-do global sync, which is the add to-do publish we talked about during the presentation. And you can see the subscription is listening to the add to-do global sync. So this is the mutation that will be triggered, that will be invoked from the Lambda function, which is triggered by the DynamoDB stream. Okay? So let's also have a look at the DynamoDB. So this is the table within DynamoDB. For the configuration is the DynamoDB table. You can see the replica is in Singapore, in the Singapore region. So any change I make in the island is duplicated to the Singapore region. And you can also see the streams as well. So I talked about leveraging the DynamoDB stream, consuming that stream and using it to, which will trigger the Lambda function. So this is the setup for the Lambda, for the DynamoDB stream and the particular Lambda function that is being triggered to call that add to do publish mutation. Okay, let's have a look, check, or something else I also want to maybe give you all as part of the session is that I have created a CDK app of the full infrastructure we just talked about in an active-active pattern. So if you go to AWS sample GitHub repo, you will see a CDK app that contains the full infrastructure we just talked about deployed via CDK. So this will create the DynamoDB tables, create the AppSync endpoint, configure the routing, all deployed via CDK app. What you just need to feed it in is just give us the hosted zone you've configured within Route 53 and specify the DNS names you want to use for the custom domain name of your AppSync endpoint, and for the routing, we'll take it up from there and deploy the full infrastructure. So test it out, and we want to get your feedback as well. And when you deploy it, you can test it. There are instructions here on how to test it with Postman as a client, so you mustn't use the Amplify API libraries. And I've also added the sample to-do app we just talked about as well, a React app, so that you can test this yourself and see how that works. So you can use this repo at least to get started, deploy things, see how they communicate with each other, and then take it up from there for your own use case. So let's quickly move back to the demo. So the health check we've just talked about. I will quickly go back to the health check. So remember we flipped the switch back to on, which is simulating the Singapore region is now healthy. And our VPN is still simulating the traffic from Singapore. And once we try to create now we should expect the traffic to go through Singapore instead of Ireland. So I'm going to call it testing again from Singapore. Not to do. So you can see that failover, the request is being created within the AP Southeast 1 region as well. So you can see here we've demoed the ability to be able to have AppSync deployed in 2 regions. Again, this can be 3 or 4 regions depending on your use case. And how you can failover and fail back from one region depending on the issues. Maybe a particular region is unhealthy, and how you can failover and fail back using routing controls and based on the monitoring and alarms you've set up for your resources. Let's move back to the presentation. So key takeaways here. I think the first thing you need to think about when you are deploying AppSync in multi-region is to understand your application requirements. Do you need to go active-active? Do you need to go active-passive? And what are kind of the consistency model you need to adopt? Then you also then move on to how do you implement routing. I've talked about the 2 options for implementing routing. So based on your requirements, you can decide for the one you go with. If you want to support queries, reputations, and subscription, the option of using Amazon Route 53 with Lambda at Edge and CloudFront will help you to achieve that. And you want to make sure that you are able to identify when a region is unhealthy and route the traffic to only healthy regions. And you can do that by setting up monitoring and alarms based on the resources you've set up in that particular region. But use Amazon Route 53 Application Recovery Controller to control those health checks to help you failover and fail back as well. And finally, ensure that you've implemented an authentication method that supports multi-region. So make sure you don't have a single point of failure for your authorization mechanism, and you can use AWS Lambda Authorizer for that. In fact, in the demo we just went through, that's using AWS Lambda Authorizer. So key resources for you to take away. So the first one is the QR code for the GitHub repo I just showed you now. So on AWS sample, so the CDK app repo, that's the first QR code. The second is a blog we wrote a while back about deploying AppSync in multi-region, and then we have a reference architecture for the active-active pattern, which you can also have a look at. And if you are new to AppSync and GraphQL, feel free to get started with how to GraphQL on AWS. Finally, I want to say a big thank you for really staying and listening to this talk. It's really much appreciated. And if you have any questions, I'll be around the corner to take any questions. Otherwise, thank you so much for joining, and do enjoy the rest of re:Invent.